Welcome in, welcome in. We are going to be doing Algebra 2 polynomials. So if you know anybody struggling with adding, subtracting, or dividing and multiplying polynomials, share this live with them, please. It also will help anybody that's taking the GED, or if you have the ASVAB, that will help you as well. Happy Tuesday. All right. Hey, Elizabeth, welcome back. Thank you for the support. Okay, so let's get started. All right, so whenever you're subtracting polynomials, okay, you have to remember this first step to distribute the negative. So there's an imaginary -1 here, and you have to multiply -1 to everything in the parenthesis. So we're going to rewrite this as -4a squared minus 6a minus 12. Now, since this doesn't have a minus sign in front of it, we're going to just drop this down, okay? Now, you can drop it down vertically or horizontally, okay? I'm going to do this one horizontally. So 6a squared plus 5a plus 10. All right, and then we start looking for like terms. I need this, my final tomorrow. Oh, perfect. Well, welcome in. Good. Grab you a little piece of paper. See if you can knock these out with me. So can somebody tell me what are the like terms? What are we combining? Put it in the chat. Thank you for the double taps. Can everybody double tap the screen? Share this live, please. Thank you. You got this for liking. 6a squared. Dominique says 6a squared and 4a squared. Perfect. And then, so somebody else said, so we got here and we got here. Somebody else said the 5 and the 6. Perfect. Don't forget the signs that go with them. So we have a positive 5a and a negative 6a. And then we have, you're welcome, AC. And then we have a positive 10 and a negative 12. So we're going to start combining. 6 minus 4 gives us 2. Remember, whenever you're adding or subtracting, your your variables stay the same. So a squared. A lot of students, when they're first starting to learn polynomials, they start mixing up like, oh, do I put 4 here? No. Whenever you add or subtract, you're just changing the coefficients, the numbers in front. This always stays the same, okay? So now this is gone, okay? 5 minus 6 is going to give us negative a, or negative 1a, okay? So that's gone. And then 10 minus 12 is going to give us negative 2. And this is our answer. Good, Ernest. Yes. Love it. Okay, so let's go to number 2. Okay, so we had a subtraction sign, so we had to change the signs. This is a plus sign. So when you see a plus sign, you're just looking for like terms. You don't have to change no signs. You're just looking. We have x squared here, 2x squared. So we're going to combine those. We have a negative 3x and a positive 7x. And then we have a negative 3 and a minus 2. Okay, so let's combine these. If we have 1 plus 2, that's going to give us 3x squared. And then if we have negative 3 plus 7, we're going to do 7 minus 3 is plus 4x. And then we're going to get, what do we get for the last one? Can you guys put it in the chat? Good. -5. Wonderful. Yes, -5. Remember, somebody owes you $3. They say, let me get 2 more. They owe you a total of $5. Perfect. All right. Wonderful. Can somebody tell me what we're going to get? This is addition. So what's our first term going to be? when we combine these, what do we get? Yes, you are smart. Oh, thank you. Is that Joker? Joker? Good. Okay, so negative 4f squared minus 6x plus 3. 4x squared. Ooh, okay. Yes, don't forget the negative, else that's going to throw off your whole entire answer. Negative 4f squared, okay? And then we have, somebody said it, negative 6, because we have this negative 3 minus 3. So we're going to get negative 6f. And then we have negative 5 plus 8, which is right here. Well, I should have done a different color. But these are like, let's do a different color so people don't get confused, because we don't want to confuse anybody. So negative 5 plus 8 is going to give us plus 3. And that is adding and subtracting polynomials. Okay. All right, let's go to the next. Let's go on. All right, so we got a little bit more subtracting and adding, and then we're going to jump into some multiplication. Okay, we're going to do some multiplying polynomials here. And then hopefully, if the baby allows, we'll get to some division. Okay, so let's go to number 4. So don't forget, remember our first step, we have a minus sign here. So we have to change every sign here. So we're going to get negative 4b squared. This negative has to go to a plus 2. Okay. Now we're going to drop this. So we're going to do 7b squared plus 6b minus 7. All right, let's get these like terms. Somebody tell me what's my first thing that I'm combining. Ooh, Jay said negative 3b squared. Oh, is it? Oh, no, you said 3b squared plus 6b minus 5. Love it. Anybody can second that? You guys agree, or you got something else? 3b squared plus 6b subtract 5. Love it. Okay, agreed. So 7 minus 4 is going to give us a 3b squared. We have this plus 6b. And we don't have any other b, so we're just going to drop that down. Plus 6b. And then we have a negative 7 plus 2. So a negative 7 plus 2 is a negative 5. Oh, yes. And that is our answer. Okay. Thank you, Jesus. Okay, so number 5. We don't have to do nothing except combine. What do you guys get? Let me see you guys try this one in the comments. What do we get for number 5 when we combine this and this? I take requests, but since I post these lives on YouTube, on my YouTube, like you would request it and then I would do it like the next day, but not like while I'm in here. So what did you say? Good. I have the TSI test next week. This is helping. Yes, this does. Oh, congrats. I hope you do good on it. I'm glad you're here. 3G plus 12. 3G plus 12. Excellent, you guys. There is a 1 here always. And so we get 3G. 5 plus 7 is 12. Hi, are you talking to the people? Yeah. Let me pick you up. Okay. All right, number 6. Okay. Can somebody tell me what we're going to do? What do you guys get when you distribute the negative? Okay, Pythagorean theorem. Oh, you have a test tomorrow? Oh. I might be able to do one before I get off. Combine like terms. See, we can't combine like terms yet because it's a minus sign. So you always have to, good. Jaden said negative 3x plus 4 minus 7. You have to distribute the negative first. And for my juniors that are taking their ACT, this problem is like 99% on the ACT. They're gonna give you one of these. Good. So we have negative 3. This minus sign goes to a plus. And this plus goes to a minus 7. And then we're gonna drop down our x squared plus 2x minus 5. And then I like the highlighter. If this helps you, get you some highlighters. And then that way you can see like what are alike. So we have a plus 2x and a plus 4x. And we have a minus 5 and a minus 7. All right, so what do you guys get? Jaden said negative 2x squared. Yes, Jaden, you are on it. That's what I'm talking about. So we have 1 minus 3. It's negative 2x squared. 2 plus 4 gives us 6x. And negative 5 minus 7 gets us negative 12. So if you got that, wonderful. If you didn't, it's okay. Make the mistakes now so you can bust it out, right, on your test. Thank you so much for the rose. Thank you, thank you. All right, let's jump into some multiplication, okay? Let's get into some multiplying polynomials. So, this one is, have you heard of binomial? And this is a monomial, okay? You got to start getting used to this like math language so you can, so when they say, oh, you're distributing a monomial times a binomial, you know what they're talking about. So a binomial is just two things that are together that add or subtract. And a monomial is just like one thing. I don't know. That's how I explain it. It's like a letter, a number, both, but it can't have a plus sign between them, if that makes sense, okay? So we're going to distribute, which just means we're just going to multiply. Now, we're doing 3p times np. We're going to do 3p. Now, I want to see what you guys say. P to the what power? Use the FOIL method for the two binomials. Okay, I can do that. Squared. Kaylin said 2, 2, 2. Good. Because we have two p's here. So we have to put p squared. And then don't forget, we have to also add the n. Good. Then we're going to do 2p times z. This literally is not going to make sense, right? 3 times a negative is a negative 3. And then you just put the p and z together. I think what trips people out is because it's like, okay, what is 3 times z? Like, no, it's not going to never make sense. You just squish it together. When anybody asks you a number times a letter, you just put them all together. What's up, man? Hey. Okay. It says, why is the N on the outside? Oh, it could be in the inside or the outside. Really, I should have wrote it in alphabetical order. So I was thinking P comes before N, A, B, C, D, F, G, H, I, J, K, L, M, N, O, P. Oh, I said it wrong. Yeah, so the N could have been in the inside if I was going alphabetical order. So, but you could have wrote it like this. 3np squared minus 3pz. Why not like 3np? Yeah, you could have written it like this. That's a great question. This and this mean the exact same thing, okay? Because they're all multiplied together. So this is the same. Both of them are correct. Okay. All multiplications, so the order N and P doesn't matter. Yes, Jen. Yes, good. What grade will we learn this? You will learn this in, well, it depends on what track you are in math, but you can learn this for sure in Algebra 1 freshman year, or you'll learn it in Algebra 2 junior year. All right, so let's try this one. We're going to distribute here and here. We're going to multiply. So we're going to do 4 times 2 is 8. And then x times x squared. We get x to the 3rd power. And then 4x times y is just 4xy. Squish it together. All right. Now, number 9. People are asking for the FOIL method. Okay, so FOIL is first. So let's write out what FOIL is. Now remember, FOIL only works when you have 2 binomials. When you have 2, like one here and one here. Binomials, these are binomials. Remember, 2 terms that are adding or subtracting. Okay, so FOIL, we're going to do our first. So we're going to multiply those. So 2x times 3x, gives us 6x. How many x's do we have? Squared. Okay. And then we're going to first FOIL outers. So we're going to go here to our farthest to the left, farthest to the right. So we're going to do 2 times a -5. So 2 times a -5 gets us a -10x. And then we're going to do our inner. This is our innermost, which is right here. -3 times 3x gets us -9x. And then our last for the L. Oh, do I have another color? Yes. Let's do black. Our last. So our last in each parenthesis. So -3 times a -5. A negative times a negative is a positive. And 3 times 5 is 15. All right. What do we do next? Can somebody tell me in the chat? What are we doing next? Thank you for the double taps. Can everybody take a second? Can we get this live to 5,000 likes? Like terms, add the same numbers, combine like terms. Good. Okay. These are our like terms. Oh, somebody asked a question. For number 9, isn't there also a box method? It's less confusing. I love the box method. Yes, I love the box method. So yes, you can do the box method, but I saw a lot of people ask for the FOIL, so that's why I'm doing it this way. But me personally, I love the box. -10x minus 9 is -19. And I wouldn't say it's less confusing. It just depends on how your brain works, right? Like some people feel like this is way easier than drawing the box out and then putting them in their places and then multiplying. So it all really depends on how your brain works. Can you show us the box method? 100. Yes. Thank you for asking. Yes, I can. All right. So we have a little space over here. So we're going to draw a box. Ooh. So I'm going to draw a box. Boom, 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 boom. Okay. And then let me put this up here. Boom. We're going to go here. Boom. And we're going to go here. Okay, so like this is what I'm saying. You would have to like draw your box, right? Because it's not going to be given to you. Now, how you use this is like the old school multiplication chart. Thank you, Joy, for the teddy bears. Thank you, thank you. You put your first binomial, you can put it here or here. You have to decide and then you make the decision, okay? So we're going to put 2x here. And we're going to put the -3 here. Now, I could have wrote it up here. There's no wrong way. You just have to choose and go with it. I'm going to put my 3x here and my -5 here. Now, you have to go back to elementary. Those old school multiplication charts. That's how you fill in these boxes. So 2x times 3x. 2 times 3 gets us 6. And x times x gets us x squared. Can you guys tell me what's going to be in this box? -43. What does it say? Yeah. -10x, -10x. Wonderful. Yes. 2x times -5 gets us -10x. Great, you guys. All right. How do we get this box? Somebody let me know. How do we fill in this box? What are we multiplying? Yeah, we're still in Algebra 2. This is all Algebra 2. Ooh, -9x, -6x, -9. Good. Don't add these. We're multiplying. So -3 times 3 is a -9. Drop the x with it. Good. And then -3 times a -5 gets us a +15. Now what we have to do is we have to take our inner 4 boxes here. And we're going to multiply. We're going to write them out. Okay. So we would write them out just like we did here. So we would do 6x squared minus 10x minus 9x plus 15. And then you would combine those and do just exactly what we did there. But that's the box way. Does the order matter? Not at all. Some people go this way. Some people go like this. It does not matter. You just have to know what are the like terms that you're combining, though. Great question. Thank you so much for the people that are asking questions and helping me answer them because I can't see them all. Oh, good. I'm glad you passed honors algebra. Thank you for the roses, Minnie. All right, so let's go to number 10. Okay, we're going to distribute here. Okay, boom, boom. That means we're going to multiply. So -5 times 2 is -10c squared. What do we get here when we distribute this? Can somebody let me know in the chat? I'm teaching algebra 2 polynomials. Multiplying, dividing, adding, subtracting, we're doing it all. Plus 5d squared. Wonderful. Yes. Don't put that minus sign. A negative times a negative gets us a positive 5d squared. Because remember, there's an imaginary 1 here. So we're multiplying -5 times a -1. That's how we end up with a +5. Aw, thank you. I know I miss you guys too. I'm so happy to be back. Fato, thank you. Yeah, I had my baby boy, my last one. And so, you know, that takes a while to get used to having 4 kids now. So it's been a transition, but it's been good. Oh, thank you guys. Thank you. Thank you. I'll miss you guys too. I'm glad to be back. I feel the love. All right, let's do number 11. Okay, so this is where you cannot use FOIL because you have a binomial and a trinomial. This is a trinomial because you have 3 terms here. 1, 2, 3. Okay, so I'm going to do the box because I love the box. So I'm going to do what I'm going to do. How I'm going to do this box. I'm going to do it like this. Boop, boom. And then I'm going to do like this. Okay. Okay, so I wrote my box. Since I only have 2 spots here, I'm going to put my x and my negative y here. My binomial over here. And then I put 3 boxes up here for this trinomial. So I'm going to put x squared, 2xy, and then y squared. Okay. All right. X squared times x gives us x to the third. Okay. Can you guys put what we get in this box in the chat? What do we get when we what are we multiplying to get this box? X cubed, good. 2xy, 2x squared y. Yes, wonderful. 2x squared because we have 2 x's here and a y. Great. Because we're doing 2xy times x. Well, x times x is x squared. So it's 2x squared y. You literally just put it together. So we have x times y squared. Good. X, y squared. Squish them together. Because it's not going to make sense logical because there's no such thing as x times a letter, like a letter times a letter. It's just like, what? So you just squish them together, okay? Here we have negative y times x squared. Well, it's going to be negative x squared y. We're trying to write them in alphabetical order, okay? All right. Now we're going to do negative y times 2xy. Okay, this is where it starts to get crazy, right? A negative times a positive is a negative. We have the 2. We have the x. And we have 2 y's here. So we do y to the second. See how we're breaking down? See how I'm breaking down each little thing in there? I hope that's making sense to you guys. And then y squared minus times a negative y to the third. Thank you so much for the rose, Joe. Okay, now what we have to take is we have to take all these inner boxes here. Okay, so I'm going to write those out. So I'm going to do x to the third. Okay. Now, do you see how these 2 boxes are like terms and these 2 boxes are like terms? It's always going to be like that when you do the box method, okay? The diagonals are the like terms. So I'm going to put plus 2x squared y minus x squared y. And then I'm going to go back here, plus xy squared minus 2xy squared minus y to the cubed. This looks crazy. Trust me, I know. But we're going to combine these. So 2 minus 1. I'm going to drop down my x to the third. We're going to have 1 x squared y. Now you could put the 1 there. It's technically not wrong, but if you're having multiple choice tests, they're never going to put the 1 there. And then what do we get for this next when we combine this? Can you guys put it in the chat? What do we get when we combine these 2? Oh, good luck on your Algebra 2 honors. Good luck on your test. Take your time. Not too much time though. We run out of time though. But just go slow. Double check your steps. You got this. Good. So you guys are putting negative xy squared. Wonderful. Negative xy squared. And then we're going to drop down our negative y to the third. And this is our answer. Where was this yesterday for my finals? Oh, man. I was on here yesterday. What was I doing? Oh, solving equations, pre-algebra. And then I had a lot of people in my live yesterday ask for polynomials. That's why I'm doing it today. So that's how I work. Okay. So what happened to the 2? Oh, Well, what happened to it is there's an imaginary 1 here. And when you are combining like terms, you're doing 1 minus 2. So 1 minus 2 is a -1. So it goes away. Yes, I do college algebra. Yep. Okay. All right, let's do number 12. Let's see. Do we want to do it a different way, or do you guys want to do the box way? Do we want to do it a different way? Could you do square root binomials? Okay, different. Okay, I'm getting a lot of difference. I don't have any square root problems in this lesson because it's polynomials and square roots are not polynomials. So I can do that. Oh, actually tomorrow I'm doing ASVAB. But I'll put that on the list to get to do. And if I don't do it live, then I most definitely will try to post a video on my page, okay? With square roots. I know what you're talking. I think you're talking about rational. Is it rational roots? Okay. So everybody said a different way. So since we're gonna do it a different way, I'm gonna do the distributive way. So I'm gonna do a times a to the third minus 3ab minus b squared. And then I'm gonna do plus b times this whole thing again. A to the third minus 3ab minus b squared. This is the distributive property way, okay? Like I'm distributing. So I'm gonna go here, here, and here. So we're gonna do a times a to the third, a to the fourth. I have 3 here, 1 here. I have 4 of them now. A times this is going to be minus 3. I have 2 a's here. So a squared b. A times this minus ab squared. All right. The ordering is confusing. Yes, it can be confusing at times, but you just have to keep the order that it's giving you. Look, like I just dropped down the 3, I dropped down the b. I have 2 a's now, so I'm doing a squared. Here, I put the a in front because it's alphabetical order. Oh, it's going blurry. Hold on. Can you guys see it? Okay, sorry. All right, we back. So, what do you guys get? Oh, why is my phone going blurry like this? Oh, hold on. Oh, man. My camera's tripping. Is it just blurry to me or is it blurry to you guys? Yeah, it is. I don't know why it's doing that. Okay. It stopped. Us too. Okay. Now it looked like it focused in. I don't know why I was doing that. Okay. All right. Better. Good. Okay. So now let's distribute here. Okay. Remember, we're going in alphabetical order. So b times a to the third is plus a to the third b. And then we're going here. Negative 3a b. How many b's do I have? I have 2. So b to the second. And then we're going to go here. Negative b. I have 2 here plus 1 more is 3. All right, let's highlight some like terms because it just helps with my eyes. Sometimes I'd be like, what are the like terms? So we have, do we have any? A to the a second. I don't see any like terms, you guys. A, B second. Oh, I do. Negative A, B's to the second. Negative 3A, B to the second. Those are the like terms. That's it. There's 1. Yes, good. All right. So we're going to drop down everything else. A to the 4th minus 3a squared b. What do we get when we combine these, you guys? Can you guys put it in the chat? What do we get? -4. Good. Yes, because there's a 1 here, so we get -4ab squared. Somebody said, how do we know if they're like terms? They have the exact same letters or variables, okay? Whenever somebody says variables, they're talking about letters. Thank you so much for the gift, AJ. Thank you, thank you. So we get -4ab squared. We're going to drop down our a to the cube b and our minus b to the cube. And that's our answer. That's it. Thank you, Liz, for the bear. Thank you, thank you. Is this algebra 1? No, this is algebra 2. This is algebra 2. But you might do this a little bit in algebra 1. Thank you for the bear, you guys. I really appreciate the gifts. Thank you, thank you. Oh, and I post all my lives on my YouTube. So if you guys could do me a favor, go over there, follow me. My YouTube is on my profile. I would greatly appreciate it. Okay, let's keep it pushing. While little man's letting me. Okay, so we have more addition and subtraction, and we have this kind of multiplication, this one, or we can jump to division. He's being good right now, but I don't know how much longer it's gonna last, to be honest. So do you guys want to jump to division? Division, yeah, okay. Oh, division, please. Okay. All right. So let's jump to division. And then, because I did want to do a couple of division. We already did addition, subtraction, multiplying. So let's do some division. And then if he's still good, we'll go back. Okay. All right. So this one is dividing trinomial. 1, 2, 3. It's a trinomial divided by a monomial. Okay. So what we're doing here, you see this -1? How this could be written as is 24 a to the 4th, b to the 3rd, plus 18 a to the 2nd, b to the 2nd, minus 30. We're just copying it down, but it's all over this 6ab. So when you have this -1, that's telling you this thing is in the denominator to get rid of the negative exponent. These are your exponential rules that are coming back to Hannah's, right? So when you see division like this, you have to understand this 6ab is going to each and every term. You're dividing it into each of these. So if we're looking at 24, a to the 4th, b to the 3rd, and we're dividing that by 6ab, we're going to do the division here. 24 divided by 6 is 4. Can you guys tell me, what do we do with the exponents when we divide variables? What do we do with this? What's the rule? Subtract, subtract. Good. Minus. Yes. Wonderful. No, we can't add them. That's when we are multiplying. We add them. When we divide, we subtract. So think of division like as a little subtraction bar. And you have to know that there's always an imaginary 1 up here. So I'm doing 4 minus 1, and I'm getting a to the 3rd. Good. KF said b to the 2nd. Yes. So a to the -1 is also 1 over a. Yes. So this is the exponential rule. When we want to get rid of our negatives, we put them in the denominator. It goes from the numerator to the denominator. Okay. Thank you for answering that. All right. So let's go here. So we're going to do plus 18a squared b squared over 6ab. 18 divided by 6 is 3. Okay. Remember, we're subtracting here. 2 minus 1 is 1a. 2 minus 1 is 1b. So 3ab. Why is it that the only time I pay attention to math is when it's on TikTok Live? I love it. I know. I always tell my students, I only think you pay attention when you go back and you, like, if I'm teaching a lesson, they'll go on my TikTok and be like, oh, I just learned it in three minutes, Miss Taylor, instead of this 90-minute class. I'm like, whatever. It's literally all your friends. That's why. Distracting you. All right, so let's do this one. Can you guys tell me what you guys get for this last one? Put it in the chat. Negative 30ab to the third divided by 6ab. What do you guys get? We got 5b squared. Ooh. Negative 5b squared. Negative 5b squared. Yes, good. Don't forget that sign. A negative divided by a positive is always a negative. 30 divided by 6 is 5. These a's, somebody said, they one on top, one on bottom. A divided by a goes to a 1. They cancel. You have 1 here. 3 minus 1 is b to the second. And this is our beautiful division. Good. I'm glad you're here for this refresher. Okay. Oh, good. You're doing this right now in class? Okay. So let's divide here and here, okay? So again, we're doing a trinomial divided by a monomial. Okay. We're gonna do a trinomial. I think we got trinomial. I want to jump to like the long division. Okay. I do want to do a couple of those. Okay. So here, 15 divided by 3, 5. 3 minus 1 is y to the second. Okay, let's go here. 6 divided by 3 is plus 2. We have 2 y's on top and 1 y on bottom. Let me write it out because some people are more visual. These y's cancel out, so you're left with 1 y. Let's go here. 3y divided by 3y. Well, 3 divided by 3 is just 1. And y divided by y is 1. So that's why it's y. And this is our answer. Good, good, good. All right, let's get into some long division because a lot of the Algebra 2 students yesterday were asking for long division and synthetic division, right? Oops. See, it went too far. All right, so let's go here. Let's do this. We're gonna do for long division, okay? The long division way. So we're gonna do n plus 5, and remember that old school long division bar. We're gonna put n squared plus 7n plus 10. All right. Yeah, I do go over geometry. I know I have to go over some geometry proofs because a lot of people have been asking me for, they have a final coming up and they need help with proofs. So I will be doing a live probably during Christmas break with the proofs, probably like next week, okay, for geometry. Could you add, let me see. Could you add more examples of proofs on your page? Yes, I can. I'm working on it. Oh, on my YouTube though, if you go to my YouTube, I do mini lessons, like 5 problems. So I have like 2 proofs, mini lessons on my YouTube page at Impact Math 19. I still have to do angle, angle, side, and side, angle, side. I think I did. Go on there because there's like mini lessons on proofs. So yeah, but I can add more onto my TikTok too. Correct me if I'm wrong. Okay, Jeremy, I love it. Age ain't nothing but a number. All right, so let's jump into this, you guys. Whenever you're trying to divide, right, you're only looking at this first thing and you're looking at this. So you're saying, how can I make this n go to an n squared? Only way I can make this n go to an n squared is I need two of them. So that's why it's going to be in here. So n times n gets me n squared, and n times 5 gets me a positive 5n. Remember, whenever somebody says n times a number, you just put them together, 5n. Okay. Now we're going to, remember in your long division rules, you had to subtract. This is where students get a lot of mess ups. You subtract, you put your subtraction, but you forget to distribute the subtraction. So here I have to go subtract, and here I have to go from a positive to a negative because my subtraction has to go throughout. I hope that's making sense. But the opposite of what it is. Multiplying ones, please. Okay, so 1n minus 1n squared, 1n squared minus 1n squared, these cancel. 7 minus 5 gets us 2n. Okay. We're going to drop down our plus 10. Okay. Now I'm only looking here. I'm trying to make this n look like this. Can somebody tell me what we have to multiply by up here to make it look like this? 2. Good, wonderful. Yes, so I'm going to put this plus 2 here. So I'm going to do 2 times n, which is going to give me a 2n. And 2 times 5 gets me that plus 10. Now again, I'm subtracting, but I'm not just subtracting here. I have to change all the signs because I'm subtracting all the way through. So 2 minus 2 goes away. 10 minus 10 goes away, where we have a remainder 0. This is our answer. Oh, good. Everybody has their finals. I'm in Wisconsin. We don't have finals till after Christmas break. Like, I think ours ends in January, February. Julian, yes. Okay, let's do it. Let's try another one, okay? So we have t plus 6. Do that division bar. 2t squared plus 13t plus 15. All right. We should do one with a remainder? Yes, I know. I think both of these are ones without. I'm not sure, though. Okay, so here we have t. Remember, I'm trying to look only at this. I'm looking at what can I times this by to make it look like this? Can you guys put it in the chat? So what am I timesing this by to make it look like this? What do I need? T, a 2t, 2t. Yes. I need a 2 and I need another t because I have t to the squared. Well, the only way I'm going to get this t to the squared is if I have a 2 t's and a big 2 is in front. So 2t times t is 2t squared. Then I have to multiply here. 2t times 6 is 12t. Again, you're subtracting, but you have to subtract all the way through. Okay. This cancels. And then 13t minus 12t is 1t. Drop down that plus 15. All right. What am I going to multiply this by in order for it to just be a t? Can somebody tell me? One. Yes, 1. Good. So we're doing plus 1. 1 times t gets us t. 1 times 6 gets us a plus 6. Again, we're subtracting, so we have to subtract all the way through. 1t minus t, that cancels. 15 minus 6, 9. So now we have a remainder. We have a remainder of 9. Now how you write this is since it's a positive 9, we're going to do plus 9 over what we divided by, t plus 6. And that's how you write your answer. You should use parentheses when you subtract. Yes. So like what they're saying is, so I had here n squared plus 5n, right? I'm subtracting. So to show why the subtraction goes here is because really you're distributing this -1. You're timesing the -1 here. But you're really just, you're subtracting everything on this row. Everything on this row. Everything on this row. But yes. Yes. Yep, and this is algebra 2. Somebody said I'm 25. What kind of math is this? Algebra 2. Dividing. All right. Somebody's asked for, okay, so we do have a couple of more division ones, but they're with monomials. Do you guys want to do this, or should we do a couple of multiplications? What do you guys want to do? Multiply or divide? Somebody said you broke me on the last one. Oh no. It's that remainder stuff. That's why. More division. Okay. Can you do synthetic division? I didn't really plan for synthetic. I'm gonna do synthetic on my next one, okay? Because that's like I guess, yeah, we have to do it on the next one. Because we would do synthetic division with this kind, not with this kind. And I don't have any more of those long division ones. So sorry. I'll do it on the next one, okay? So here we're dividing by each of these by, so we're going to do 24 c to the 5th d, and we're dividing by 4 c d. Okay, 24 divided by 4 is 6. What do we get here? What operation are we doing with these variables? Are we adding, multiplying, subtracting, dividing? What are we doing? C to the 4th. Good. Subtraction. Wonderful. 5 minus 1. Remember, there's always a 1 here and here. So we get C to the 4th. These D's are going to cancel. Why they cancel is because really it's D1 minus 1. Remember, anything to the 0 power goes to a 1. That's why we just say they cancel out, okay? All right, that's why we do that. All right, this next one, if we divide this by 4CD, -8 divided by 4 is a -2. Don't forget that sign. C's cancel here. And we have D2 minus 1, just 1 D left. Okay. Over here, we're going to do 4CD. 12 divided by 4 is a +3. We have 3 and then 1 on the bottom. So we're left with 2 D to the 2. And this is our beautiful answer. Yes, this is algebra 2. Lex, this is algebra 2. Yes. Oh, don't let this give you a headache. No. Why do you always subtract? Oh, somebody had a great question. Okay, so why do you always subtract though? Because that's the exponential rule. The exponential rule says when you divide variables, you subtract their exponents. Only when you're dividing the variables, the letters. you subtract the exponents. That's the exponential rule. Do you do all math to help us old people with kids in high school? Yes, I do all math. Yes, yes, yes. I even do college math too. Oh, I'm learning this in Algebra 1 honors. Good, Lex. Love it. When's your next live gonna be? So my goal is to go live every day, you guys, to end the year out. So, but I don't have a scheduled time because, I have a newborn, and then I have, and then I tutor on top of that. So it's like I just get it in when I can fit in, to be honest. Oh, thank you. So the math that I do, I really do like GED, HESI, T's, ASVAB. I try to do those type of tech jobs to help people, level up in their life. That's my real passion, is working with like young adults or even old adults that trying to just get a level up, and math is stopping them. I'm going to start ACT math when it gets closer. We take the ACT out here in Wisconsin in March or May. No, March. So I'm going to start that in the new year, getting ready for that. So be on the lookout. All right, let's finish out with this one, you guys. So remember this -1? If we want to get rid of this -1, this has to go in the denominator. So we're doing 12y to the 5th divided by 3y to the 2nd. Okay, I'm going to write them all out. Minus 8y to the 4th over 3y to the 2nd plus 15y to the 3rd. Remember, this 3y to the 2nd has to go to each and every single term, okay? 3y to the 2nd. All right. Can you guys tell me, what do we get for this first one? Can you guys put it in the chat? What are we getting for this first one when we divide it out? Oh, I wrote the second one wrong. Thank you. Thank you. Yes, I did. 4 here. Thank you. Thank you. 4y to the 3rd. Good. So we get some, it's like so crazy. Like sometimes my brain always like already did the work because I was like doing it, but sorry. That's why I wrote 2 there, but my bad. So 12 divided by 3 is 4y to the 3rd. Wonderful, you guys. Good, good, good. Okay, what about here? What do you guys get here? -8y squared divided by 3. Good. Remember, we cannot subtract these because this is a division bar. So we can't do -8 plus and 3. Remember, this is -8 divided by 3. These are not alike. And then we have to do 4 minus 2. We get y to the 2nd. So we literally leave it like this. Yes, it stays the same. Good. Yes. Don't let your mind play those tricks on you where you start to subtract things. This is division, okay? But of course, make the mistakes here so you can ace it on your test. 15 divided by 3 is a +5. We have 3 y's on top, 2 on the bottom. We're left with 1. And then minus 24 divided by 3 is 8. And these, we have 2 on top, 2 on bottom. They cancel each other out. That's our beautiful answer. Okay. All right. Thank you, my beautiful people, for hanging with me on a Tuesday night doing some math. Oh, you have a question? Put it in the chat. Oh, so we don't keep that last one? No, you don't keep this last one because you have y over y, y over y. So all the y's cancel out. You're so welcome. Okay, so somebody said, hold on. What is your next live going to be? I'm going live tomorrow. I don't have a time yet because I think I know I have some tutoring tomorrow. But it'll either be like at 7 or it's gonna be a little bit earlier, like around 4 or 5. One of those. And I'm in Central Time. Okay. All right. Where do you post the time? I don't post the time. I just jump on right now. Hopefully in the new year I'll be more consistent with the like set time. But right now with the newborn 4 kids, it's like get it in when you can. All right, my loves, have a wonderful night. And I will most definitely catch you on the next one. Bye. Thank you so much.